Hello everyone. We are in this part of this lecture and today we are going to consider about clustering. As I have mentioned earlier, clustering is a part of data analysis steps, and this clustering is called unsupervised learning mechanism in data mining. But from the big data analytic point of view, you can consider this is a data analysis process in which we can model and we can cluster the data. Well, we are still in the data processing stage, right? So let's look at what is clustering. We have already seen about regression and classification. These both comes under the so-called supervised system, whereas clustering is an unsupervised system. Let's see why it's called an unsupervised system in the coming slides. Okay, let's define what is a clustering. Well, clustering or clustering analysis is defined as a task of grouping a set of objects in such a way that objects in the same group called a cluster are more similar in some sense to each other than to those in other groups or clusters. So as the name suggests, you can see that clusters a group. So we are going to determine how we are going to group, what is the factors that we are going to consider, and basically the definition states that the clusters as a group which are more similar in some sense. There should be some relations in which we can call similarity of those objects in this group, and we'll also consider what factors or what simple mathematical terms that we use for measuring similarity. Okay, let's go in and see the goal of clustering or cluster analysis. As the main goal is to find similarities between data according to the characteristics found in the data and grouping similar data objects into clusters. So that is our main objective, is to just find similarities between data. And then if you find this group of data has some similarity, you can group this together as one clusters, and there is another set of data that they have similarities, and we are going to group that together as another cluster. And this is called so-called the unsupervised learning, or in other words, you don't know its label in advance. In other words, there is no predefined classes. Consider this example. Suppose you are given with a document, and this document has some words related to like students, classroom, lecturer, professor, and you can add some library. There are more such words are there in this document. Now, what do you know about this document? Initially, you are just given with the document and you don't have any idea what this document is about. But now you are trying to find or trying to count the words in the document, and you find that the words like school, semester, students, classroom, library, all these things appear quite frequently. So once you count these words and you find that these words are popping out quite often, and now you know something about this document. Yes, initially we don't know what this document is about, but now after just counting the words in the documents which are repeated, like for example student, professor, exam, or classroom, it's been repeated few times in this document, and now you know that this document has something has to do with the school, or something has to do with academics or university like college. Yes, initially you don't know what it is, but now you can actually define, or you can just give a label. Like even before defining or labeling, you can at least group together all those documents which has this similarity. Now you are taking the second document, and you also have a similarity of that of the first document. You're having all those words like student, professors, the classroom is being repeated few times in another document. So then you put these two documents together. If you have another document has a similarity like those two documents, you put together, and this three document forms a cluster. And you have another group of document that talks about, say for example, sports, then you are going to group them together as another cluster. You don't know exactly what the label is, but you are sure that this new document that talks about the sports doesn't belong to this group, because they are related in some sense with those related words. So that's the basic goal or idea. So that's why we call it as like some standalone tool to get insight into data distribution. So that's why it's very important for our big data analytics to get some insight into how the data are distributed or how the data are spread in this space. It's again pre-processing steps for other algorithms, and in machine learning terms you can actually do a lot of stuff using this clustering. Let's go further and see a few more points on this unsupervised system. As I told you earlier, we have no information about this whole object, but now you know that this group, say for as I gave this example of documents related to school, and you don't really have the label, but you know that these three documents here as grouped together, and then you have another document coming in, you find similarities of like few other documents that talks about sports, so you group them together, and then you have another few documents comes in, and you find that these documents, say for example, they talk about let's say they talk about USA or Mexico or some countries. So then you are going to group them together as another cluster. So as you can see here in this picture, we can also see there are three different clusters has been formed, or group has been formed: the blue one, the red one, and the yellow one. Yes, that's kind of the output that we got out of this clustering mechanism. And after which we have to redefine and refine this whole cluster together, and finally, without any predefined labels, now we actually separated these groups. Let's see this simple so-called algorithm for the nearest neighbor. Okay, given a document, say for example, given an article A as an input, and you're asked to find the most similar article out of all the articles that is in this corpus. When I say the word corpus, it's the whole domain of all the documents that you have in hand, or all the files that you have in hand, all the articles that you have in hand. Okay, that's where you are going to search. And again, you have to define how you are going to search. Are you going to search for the words, and how you are going to find the similarity? We'll see a touch of that later on, but let's look at this algorithm now. And this algorithm is quite simple. It talks about just search over each articles, like you have say 100 articles there in the corpus, and then like x1, x2, x3, each one you are trying to compare with that of the existing article, that's the query article. Say you have this query article is this A1, and you can just compare this with the, as if you're the reader and you're reading an article, and this article say it talks about astrology, or it talks about space, say for example, and this article A talks about astronomy, for instance, and you're reading this article A, and we have to recommend another article from the whole corpus, or from the whole set of articles that is available to us, which is similar to this article A, similar to this astronomy article A. So now we are going to compute the value of say x, for instance, and you are going to see the similarity between A1 and x1. You know that we have 100 articles, x1 till x100. or xn, for example, any number of articles in the corpus. And if x1 is similar to, okay, I think this should be here, x1 is similar to a1, then you are going to, this is got to be a1. If x1 is similar to a1, then you are going to use this factor. In fact, I should go back a little bit here. Let's erase this. Okay, I think I just made simple mistake there. If x1 has the similarity score, and then you are going to store x1, you are going to store or save x1, because you already compared a1 article with x1 article, and now we find that x1 article has some similarity score. So you are going to save or store this x1, and then you are going to compare with other articles in the corpus until xn. Say for example, in our search we found that x21, the so called x21, and another article which is more similar to that of the a1. So we going to save that, and we are going to replace x1 with x21, and the output is going to be x21. That's the idea, a simple query mechanism in which you are going to compare. But in this example of the nearest neighbor, the main objective here is to get the output of the most similar article among all the articles that is available. So we are expecting only one output. But there is another simple algorithm similar to that of the nearest neighbor, the one nearest neighbor. Now we have the k nearest neighbor. Again, it is very similar to the previous one. You have a query article as the input, and you are getting the output as the list of k similar articles, not just one article, but all those similar articles. You can rank it up, like for example, if you are expecting like 10 or 15 similar articles, then you can suggest those similar articles. Of course, you can suggest according to their rank or according to their similarity percentage or ratio. Okay, so this is the stages of clustering. So here, as we input your object or your file, in our example we are going to input the article as the input, and you are asked to extract certain features. So feature selection is done, that is where the extraction happens. So in the previous example that I told you, for instance, if we are talking about say astronomy, then you are looking at some words and you are going to extract those words, those features from it. If you are talking about an article about the school, of course you are going to extract. You are extracting the words, the group of words, and you are trying to see a pattern. So as far as the article about the school, that talks about students, professors, semester, classroom, library, and so on. So you are having this pattern, and this is what you are counting, these things, and it's kind of an extraction from this article that you have in hand, and you are finding the similarity. There are two types of similarity you can consider, and later on I will just give you some brief information about that. This similarity, again, you are going to take out the similarity, and then finally based on the similarity you are going to group each article or each objects. That is where you are grouping, like in the previous slides we saw, like there are three groups have been grouped together, and those grouping eventually is what we call as clustering. If you want this system to be more efficient, yes, we can use the iterative mechanism, like kind of feedback loop, so that your similarity measure is again defined and redefined. Moreover, whenever you have a cluster, you always have a cluster center, and that can also be refined further, so that we finally get into some kind of convergence of the whole system. So this is basically the stages of clustering. Let's look in further on how this happens. Yes, I talked about the cluster centers. As you can see here, there are three groups or three clusters, one with the green one, the blue one, and the red one, and you have different shapes that define this clusters as well. So we are having this measure, and then you have circular oval shape, and then again you can consider certain things from this group. Let's consider, like, you have this center of this groups, and the main important part is that as far as all the objects that belong to a particular groups, let's say group blue, as far as all the objects that are related to this blue, they should be closer to the center of this cluster. That should be the main idea. We want all the objects to be closer to the center of this blue cluster. In other words, the distance from the center to those of all the objects that belong to blue should be minimum. We call it like interdistance. The distance within the cluster should be minimum. It should be as far as minimum. It's good if it's quite less, the distance from the center to that object within the group. But as far as different cluster itself concerned, we want to have larger distance between each clusters. We don't want two clusters to be too close. So that's the basic idea that we have here. So like we can try to find these distances that what I mentioned. Like, suppose you have this blue one, and we know that here is the distance there, and we want all these distances to be less within the cluster, whereas between clusters we want the distance to be more between each and every cluster. So still there are some ambiguity. As you can see, there are some clusters, some objects, they are seems to be part of green cluster, but it seems to be closer to the red one. So that's where we have to redefine and reiterate the system, so that you can change the cluster center or adjust the cluster center, so that we get into an optimal position where each of those cluster represent its object correctly. Okay, so we have seen about the nearest neighbor and k nearest neighbor. This is another algorithm that we have here. It's called k-means, and the k-means clustering is the unsupervised system. As I have already explained you what is an unsupervised system. We have given with nothing. From nothing we are going to establish a system from which we can group clearly with different groups based on some observation, some similarity measures. Okay, k-means clustering aims to partition n observations in k clusters, in which each observation belongs to the cluster with nearest mean. So here we are going to talk about nearest mean, serving as a prototype of the cluster. Let's see its algorithm in general, and let's see how it works. Basically, the assumption here is the similarity metric is the distance to cluster center. As I mentioned earlier, If this distance is smaller, it's better. That's our goal. Okay, now we have this, we are given with this group of objects. I mean, we have given with a list of objects, and now we are going to have clusters, like 3 clusters have been, I mean 3 different points of the clusters have been given to us. Okay, initially you are going to initialize the cluster center. So as we have defined here, we have 3 clusters, like the red one, green one and blue one. We haven't actually grouped yet, but we have just come up with the initializing the cluster center. We assume that there is going to be one cluster center with red, one cluster center with green and one with the blue. And our next step is that we are actually assigning the objects to the closest to those cluster center. So from this observation we can see that the red one is the red circle is close to this red box, I mean the square. So we group that together, and the remaining blue and green has been grouped together as well. So there is one more suggestion here, is that as red one has only one object, so, and you can still see there is a distance between the red cluster center as well as the red object. So since it has only one object, we can actually put this object right over, I mean we can put the center of that cluster right over that object, because it's just only one. So that's one way, like you're going to revise the cluster center as mean of assigned observation. So you know that there is this group of objects belong to that particular cluster groups. So as cluster center, we are going to revise the cluster center mean value, and then you are going to assign the center or refine the center again. So that's where, as far as I said about this red one, you are going to put this red cluster center right over that object, and again in the meantime you are going to redefine the other cluster centers as well. And now we are going to measure the distance between these cluster center and other object that belongs to that particular cluster. It's kind of an iteration process. Iteratively you are going to the next cycle. So that's where we are going to repeat this first 2 steps, like assigning the cluster center and assigning the observation that are closest to the cluster center. And now you can clearly observe that the red cluster center has been moved, and we found that previously the objects that belong to the green one, for example, as you can see here, previously this were belonged to the green cluster, and now they are part of the red cluster. Yes, that's how we are going to refine it, redefine it, revise the cluster center by means of its mean, and then assign its value, assign its group. In fact, you can also notice that the shape and the overall cluster size has also been changed a little bit. So that's one of the important observation you can take out from this k-means algorithm. That's the basis of this k-means algorithm. It's one of the very basic algorithm for clustering, and we do have other algorithms like hierarchical clustering and so on. So even fuzzy mean algorithm is there. So there are a lot of other algorithms. If you like, you can come up with your efficient algorithm to improve this clustering method. So let's see a simple example of document retrieval. And basically document retrieval is defined as the matching of some stated user query against a set of free text records. So these records could be any type of like mainly unstructured text, such as newspaper article, real estate records, or paragraph in a manual. So we have talked about certain examples of documents like school documents, sports document, and so on. So that's why I am also having this document retrieval as one of your example there. So let's see what is the stages that can be used for this document retrieval, and this block diagram just gives an example of a basic architecture. Not necessarily you may have your architecture as well. So I'm just giving an example that I have found from this book. So here we have this text document, and you're going to find the keyword identification. As I have explained earlier, some keywords should be identified, and then you're constructing this feature space in which you're going to distribute, and you're going to compute the similarity of two different documents. So you have all the documents coming in, and you're going to recommend, or you're going to retrieve a document that is similar to that of the document in hand, or the query document, and you're trying to find the similarity. You're going to compute the similarity. Computing similarity measures can be like a distance measure, or it can be like a simple mechanism in which you're going to see if they have the same words in both documents, and if that is being repeated. And you're going to mapping the document into clusters. You're going to group into different clusters. As I told earlier, like a group of documents can be defined as the document like school, it representing school or academics or university colleges, like that can be a group, and maybe a sports documents can be another group, and so on. You have world news documents, for example, like. And finally you are going to have this document cluster. That is the basic architecture, and that's relatively simple to understand as well. So let's see, here you have one document, and our objective is to find a similar document from the list of all the documents that you have in hand. So that is our goal here. So in order to obtain this goal, we can come up with certain mechanism. For example, as I told you earlier, we can take the articles, and you can see what are the words that stand out in those articles. So again, there should be a mechanism by which we have to make sure that the other unnecessary words should not overshadow the relevant words. As far as the document with respect to school is concerned, the relevant word is like school, classroom, students, professor, and so on. But in the same document you might have other words like the, was, it, where, and so on. Like there may be other conjunctions and other simple words. This should not overshadow. So we should have a mechanism so that we have to eradicate extremely large number of words from the document, and we have to classify, not classify, I don't want to use the word classify, we have to identify the so-called the important words, like the rare words out of this documents. So when it comes to similarity count, for example, if you have two documents, and you're going to compare these documents, and now you can see, for example, if this document is about school, let's assume that, and this document is about school as well, and this document, the first one, the second one. Now the first one has some words like student, classroom, and so on, like exam. Again, you would also have similar words here like student, classroom, exam. So you're going to see this, and you're going to look into this part, and you're going to count the number of times the word student appears. For example, the student appears 5 times, and classroom, classroom appears say 2 times, and exam appears say 3 times, and maybe this also have other words, say president of the school, maybe it appeared one time. So you are also comparing that with a lot of other documents. So here it appears 5 times, here it appears say 4 times, here it appears 2 times, here it appears say 3 times, here it appears 3 times, here it appears say 1 time, here it appears 1 time, say maybe you have 0 times as well. So there may be other words, and considering the fact that you should be careful about one important thing, there may be another word that might appear like 1000 times, for example the word the. So we should have a mechanism to eradicate those extremely large words. So in comparing this similarity ratio, we can simply we can take these values like 5 times 4 plus 2 times 3 plus 3 times 1. So that is going to be your similarity, is that 29. So your similarity is going to be 29. So whereas if suppose you are having some articles, say for example you have an article about school and there is another article that talks about, let's say it talks about astronomy, and now you find that the astronomy document does not have any of those relevant words that is in the school document. So what happens to the similarity between these two documents? Basically what you are going to have is like you are going to have other things like student, it's not going to be appearing here, or classroom, or say exams, or president, but you may have other words like space, say for example, and space may appear like maybe 10 times, and you for example if you talk about other factors like asteroid may appear 2 times, maybe planet appear 1 time, and if you find the similarity between these two, actually the similarity is going to be 0. In this example the similarity is going to be 0 since you do not have a common words, you do not have to multiply any of those things. So similarity of these two document is basically going to be 0. So that is how we compare this similarity of these two documents just by means of word count. So that is an interesting application of how we can measure the similarity. In fact, if you want to be more precise, you can actually normalize the similarity, and there are mechanisms in which we can actually reduce the effect of the overly extremely more number of words like the word the. So for this let me just simply give you an example here. Let us quickly go through this part. Say for example like you have we have this form like log number of document, log of number of document by 1 plus number of used word, like number of words in the document. We could say number of documents, using the word. Okay. So based on that, suppose I have like say I have 100 document overall. So you have like log of 100, and then you're going to have say among the 100 documents, let's say 99 documents have the word the. So 1 plus 99, so that's going to be log of 1, that is 0. So yeah, so you could see that the measure actually takes us to the value 0. Instead of this, suppose the basic idea is that the word is used too often, so we are going to take this value to 0. That is the basic idea. And also, like if you are having other words, say for example, let's talk about the word like the classroom. In all those documents, if you have the word classroom, say a number of times like 64 or 65 times, then you have a definite value there. You have certain values, so by which we can actually see the difference. You can actually eliminate those words like the. We don't want to overcrowded with these words. We don't want that to overshadow the exactly prime words that you are looking at, and maybe the exactly prime words that what you are looking at is what counts more for our case. And in summary, we can see that the clustering is a process in which we are going to group as similar objects together as clusters, and basically you are going to refine it further and try to define the distance measures and similarity measures so that your cluster looks better and precise. There are a lot of applications to this clustering, like pattern recognition, document retrieval that we have seen now, bioinformatics and machine learning. There are a lot of other applications, including the text mining, city planning, for example, like you have a list of household that has similar characteristics in one cluster. Even data mining, basically data mining, yeah, it uses clustering. So these are some of the examples, and I hope you learned something from this lecture about clustering, and there are a lot more to explore. I recommend you to explore more by yourself, and in fact try to implement it by means of some software programming things. In fact, try to use the data mining tools as well. So it's good to see you today and to discuss about this lecture on clustering, and I'm looking forward to see you in the next lecture. Till then, goodbye.